Yeah, next question is question number 31, and it says that state the reasons for myopia and with the help of ray diagrams show the image formation by a myopic eye and then the correction of myopia using an appropriate lens. Okay, so first of all, what is myopia? And the other name for myopia is uh, it's a nearsightedness. That means we are able to see the nearby objects but not the far away objects. So this it is also called nearsightedness. And with this name, nearsightedness means able to see nearby objects but cannot see far away objects. It's not that you are not able to see far away objects. You're not able to see far away objects distinctly. Means they are dull, or maybe it's dimmed. They are dimmed. So you don't have to write that you altogether cannot see far away objects. You have to write that you cannot see far away objects distinctly. You are able to see, but if there are two objects, you may not able to distinguish between them. So it's not clearly you can see the far away objects. And this is because your far point is that is infinity. Far point is nearer than infinity. Let me show you how. So uh, your far point is nearer than the infinity. We draw a ray diagram to show you that. And so myopia, as I told you, is also nearsightedness, and the person with myopia, he can see the nearby objects clearly, but cannot see distant objects distinctly. Now, a person with this defect has the far point nearer than infinity. Reason is that the far point is nearer than infinity. So far point I'm saying is you have to understand this. The far point is nearer than infinity, and then I will let you know what exactly you have to write as an answer. So far point is nearer than infinity. Now, infinity means that the far point means that the maximum distance up to which we can see an object, which is infinity. So here the far point is nearer than the infinity. So I'm going to draw a ray diagram. Let's say this is the eyeball. It may not have, okay, this is the eyeball and this is the eyelids, let's say. Okay, this is the islands, and now, as I said that the far point is now nearer than the infinity. So, so in the question it's asked, we have to find the image formation by a myopic eye. So image formation by a myopic eye, I'm going to draw the image formation by a myopic eye. So here the as I told you that the far point is nearer than the infinity, so let there be rays of light coming from infinity. So these are the rays of light coming from the infinity, and lens is this lens, which is a sort of convex lens, is not able to converge them on the retina. Instead, it's converging them in front of the retina. So this is where the rays of light are converging in front of the retina, and the image is formed in front of the retina. Take this off. Okay. So now this image is formed, and this is the retina. So image is formed in front of the retina. This is where the image is formed. And this is because the light rays coming from the infinity, they are meeting before the retina. So now this was supposed to be, so this is from where the light rays are coming. This is the far point. This is the far point. And now the far point has is nearer than the infinity. So this is at infinity, and the far point is now here. So that means the rays of light are not able to, I'm going to draw these as a daughter. Okay. Now the rays coming from the infinity, this lens is not able to convert them and focus them on the retina. Instead, they are intersecting before the retina and the image is formed here. So that means that the far point here, this is not the far point, this is the far point. And from here, the images, if from here, if this is the, that means this is the maximum distance up to which this eye can see and focus this image on the retina. So how are we going to correct this? So this is an image formation by a myopic eye. So I can write it here. This is the image formation by an myopic eye. So now this far point, which usually was here, now it has come nearer than the infinity. So it has moved here. So that means we have to correct this by using, so that means the rays of light coming from this point, far point, we have to make sure that they are focused on the retina. So for that, the corrective lens that we will use these rays of light to diverge more and then focus on the retina. So we are going to use the diverging lens, which is the concave lens. So let me show you how we are going to do that. And for that, let me copy this. Okay. So I'm going to put here the concave lens. So this is the concave lens. And now what this concave lens is going to do, this concave lens is going to divert these rays of light from here. So this is where the refraction is happening. And okay, from here, the rays of light will be diverged outwards. The rays of light will be diverged outwards. And I'm going to make this lens a bit bigger. Okay, now this is, let's say, the eye lens. So rays of light are now being diverged outwards. So that from this point, now the points from where they are being converged is nearer to the edges for the lens. So from here, these rays of light are now converged and brought back to focus on the retina. So this is how the convert divergence and then convergence is done, and the rays of light are now focused back on the retina, and this is where now the image is formed. This is not where the image is formed. Now the image is formed here on the retina. So this is where the image is formed. Okay, so this was the image formation by a myopic eye, and this is the correction. by the myopic eye. So this is the correction of myopia. You can see this is the correction of myopia. So now your far point has now moved back to the normal far point, which was at infinity. So all the rays coming from infinity are now diverged and then converged by this, diverged by the concave lens and then converge to bring them on the retina. So this is the correction of the myopia. And instead here you can also draw the lines. Just make sure that all the rays coming from here. So your far point is here. It will convert those rays of light, and so now all the rays of light coming from infinity will be converged at retina, and all the rays coming from your the myopic far point will also be converged at the retina. So this is the correction of myopia. So correction of myopia using an appropriate lens, which is the concave lens. So this is the concave lens. So what do you have to write? So you have to state reasons for myopia. And okay, we have forgot to state the reasons for the myopia. The reasons for myopia could be the excessive curvature of eyelids. And I forget to write the reasons for myopia, which could be the excessive curvature of eyelids. That means that the eyelids, excessive curvature of eyelids. This could be one of the reason. And the other reason could be elongation of the eyeball. Eyeball has elongated and the image is now forming in front of the retina. So elongation of eyeball. These are the reasons for myopia, and this can be corrected using a concave lens of appropriate focal length.